myself Satyalakshmi. We discuss an important topic. Before going to the topic, let me do an activity. See, you all can see this marker. If I throw this marker, it is again coming towards the earth. And in the same way, you all know regarding to the planetary motion. That is, sun will be at the center and all the planets will revolve around the sun. There is some force between this planet and the sun. And even if the object coming towards the earth, there is also some force between the object and the earth. And also, in case of moon revolving around the earth, there is also some force between the earth and the moon. In all these cases, the force is same? Yes, that force is same, and that force is said to be what? Contact force, which is in contact between the two things, and it is also an attractive force. And this attractive force is said to be the gravitational force. Once while Sir Isaac Newton was sitting under a tree, an apple fell on him, and this made him think, if Earth can attract an apple, why can't it attract the moon? So, by assuming these two cases, he speculated that the same type of force is acting between these two, and that force is said to be gravitational force. Okay? And this gravitational force is same each and everywhere, and hence he concluded this gravitational force as universal force. And he also gave a law called universal law of gravitation, which we'll study later. We all can observe that an object which is coming towards the earth, but we can't observe the moon which is revolving around the earth, right? For that, we can do an activity. Let me do that activity now. Let me assume this stone, which you can see, this stone as moon, and I have tied some thread to this stone, and I'll keep this thread at one end in my fingers, and this end I'll consider it as the earth. Now what I'll do, see, now it is in a straight line when there is no force. If I apply some force, that means when I whirl it, we can see that it is moving in a circular path, and at each point its direction is changing, and when I leave this, the stone will fly off. Okay? When I stop the whirling, you can see the stone flies off in a straight line as a tangent. Okay? From this we can conclude that there is some force which is acting between the earth and the moon, and that force is like in a circular path, which is moving in a circular path. If this is the earth and the moon is orbiting in a circular path, from the stone and the thread experiment, and at each and every point it is attracted towards the earth, and also it is changing its direction. If it is changing its direction, we can conclude that change in direction indicates change in the velocity or change in the acceleration. Even the acceleration will also change. That force is said to be centripetal force. That is, the force that causes the acceleration and keeps the body moving in a circular path acting towards the center is said to be what? Centripetal force. So we can conclude that the force which is acting between the moon and the earth as centripetal force. Now let me study the universal law of gravitation, which is given by Sir Isaac Newton. From the universal law of gravitation, we can state that each and every object on the earth attracts every other object with some force, and that force is directly proportional to the product of their masses, and it is inversely proportional to the square of the distance between the particles. Okay? Let me consider two objects A and B with the masses capital M and small m respectively, and the distance between those two objects is given by r. The distance is always taken from the centers of the object. From the statement of this universal law of gravitation, we can conclude that F is proportional to product of their masses. Here the object A is having the mass capital M and the object B is having the mass small m. So it is the product of capital M and small m. Let me take this as equation 1. And again from the universal law of gravitation statement, we know that it is inversely proportional to the square of the distance, and F is inversely proportional to square of the distance between the two objects A and B. Let it be equation 2. Combining these two equations, F is proportional to capital M, small m, that is product of masses by R square. What is this? This is the proportionality, and to remove this proportionality, we should use some proportionality constant. And that proportionality constant which we use is said to be gravitational constant, which is given by capital G. On equating, we will get the expression as F is equal to G capital M small m over R square.